Hello, teacher. What are we going to learn today? Are we still learning decimals?
Hello, Turbo Boy. Yes, we're going to learn more about decimals.
What else is there for us to learn about decimals?
We're going to learn how to round off decimals, or approximation of decimals.
Whoa, sounds interesting.
Glad you're feeling so excited. Turbo Boy, now I'm going to show you how to round off a decimal number to the nearest whole number.
You mean to make the decimal into a whole number? No more decimal point?
Something like that. Look at this decimal. Let's round it off to the nearest whole number.
Oh, since the whole number is 12, so the answer must be 12.
That's wrong, Turbo Boy. Look at this number line. Can you tell me which whole number is 12.9 nearer to? 12 or 13?
12.9 is more than halfway between 12 and 13. It is nearer to 13.
Good. Since 12.9 is nearer to 13, we round it off to 13.
Teacher, so I need to draw a number line each time I want to round off a decimal to the nearest whole number?
No, that is not necessary. There is a simpler way. Look at this number line. Can you tell me what number is the halfway of 12 and 13?
It is 12.5.
Good, Turbo Boy. The digit 5 is in the tens place in 12.5. When we are rounding off decimals to the nearest whole number, we look at the digit in the tens place. In this case, 12.5 represents the halfway mark of the two whole numbers 12 and 13. If the digit is 5 or greater, the decimal will be rounded up. If the digit is less than 5, it will be rounded down. Since 9 is greater than 5, I round up the decimal by adding 1 to the whole number, 12. 12 plus 1 makes 13. So the answer is 13.
Now I understand, teacher.
Good. Now try this one. Round 32.41 off to the nearest whole number.
I look at the 10th digit 4. Since 4 is less than 5, I round down the decimal. I leave the whole number 32 unchanged. So, 32.41 is rounded off to 32.
Clever boy. Now try rounding off this decimal to the nearest whole number.
Let me see. The 10th digit is 5, which represents the halfway of 52 and 53. Teacher, I'm stuck. Which one is correct?
Since the 10th digit is 5, we round up the decimal to 53.
I will bear that in mind, teacher.
Turbo Boy, can you tell me how many decimal places are there in 9.14?
9.14. There are 2 decimal places. 1 is in the 10th place and 4 is in the 100th place.
Very good. We are going to round it off to 1 decimal place.
1 decimal place? Is that the 10th or 100th place?
Good question, Turbo Boy. When we are rounding off decimals to 1 decimal place, we are actually rounding off the first place value after the decimal point, which is the 10th place.
Oh, I see. But how do we do that?
Do you remember how to round decimals off to the nearest whole number?
When I round decimals off to the nearest whole number, I looked at the 10th place. If the 10th digit is greater than or equal to 5, I add 1 to the whole number. If the 10th digit is less than 5, I leave the whole number unchanged. I get a guess. Does it mean that we need to look at the 100th place in order to round off the 10th place? If the 100th digit is greater than or equal to 5, we add 1 to the 10th digit. Otherwise, leave it unchanged.
Good guess, Turbo Boy. So can you round off this decimal to 1 decimal place then?
To round off 18.07 to 1 decimal place, we look at the 100th place. Digit 7 is in the 100th place and it is more than 5, So I add 1 to the 10th digit 0. 0 plus 1 makes 1. So the 10th digit is 1 and the answer is 18.1.
Hooray! Very good, Turbo Boy. How about this one?
I look at the 100th digit 2, as 2 is less than 5, so I leave the 10th digit 0 unchanged. Therefore, the answer is 13.0. But 13.0 is actually 13, so 13 is the answer.
Unfortunately, the answer is wrong, Turbo Boy.
Why, teacher?
The working is correct, but the answer you gave is wrong. When we round a decimal off to one decimal place, we must write out its 10th digit even if it's a 0.
I see, teacher. So the answer should be 13.0 and not 13.
Good. Let's go on to the next activity. Can you tell me which digit is in the thousands place?
The digit 7th is in the thousands place.
Correct. Now, we're going to round off this decimal to 2 decimal places.
I know that when we round off decimals to 1 decimal place, we are actually rounding off the first place value after the decimal point. Therefore, I think rounding off decimals to 2 decimal places is actually rounding off the second place value after the decimal point. That is the 100th place. Teacher?
Clever boy. When we round off a decimal to the nearest whole number, we look at the 10th place. When we round off a decimal to 1 decimal place, we look at the 100th place.
So, when we round off a decimal to 2 decimal places, we look at the thousands place, teacher?
Yes, Turbo Boy. Let us look at this example. Round off 21.347 to 2 decimal places. Here the digit 4 is in the 2nd decimal place. So we need to look at the digit 7, which is in the thousands place. Since 7 is greater than 5, we add 1 to the hundredths digit 4, and we get 5. So 21.347 is rounded off to 21.35. You try this question, Turbo Boy.
The digit 8 is in the 2nd decimal place, so I need to look at the digit 3, which is in the thousands place. Since it is less than 5, I leave the 100th digit 8 unchanged. The answer is 19.08.
Well done. What if the decimal is 13.995? What is the answer when it is rounded off to 2 decimal places?
We need to look at the digit 5, which is in the thousandth place. The digit being 5, I know that I have to round up the decimal. Thus, I add 1 to the digit 9 that is in the 100th place. As 9 is in both the 10th and 100th place, the answer is 14.
Wait a second, Turbo Boy. You've once again got the working correct. However, your answer is wrong. You need to give your answer correct to 2 decimal places. So your answer should show a decimal with 2 decimal places. Therefore, the correct answer should be 14.00.
Yes, teacher, I understand that now.
Now, we're going to do estimation of decimals during addition, subtraction, multiplication, and division.
Estimation?
Yes, it means to round off the numbers to the nearest whole numbers before we add, subtract, multiply, or divide them. Let us try with addition of decimals first. Look at this sum. Before we add them up, we must try to round off both numbers to the nearest whole number.
Okay, rounding off both decimals to whole numbers means 8.99 becomes 9 and 1.24 becomes 1. Therefore, 9 plus 1 and I get 10.
Good job! Now you try doing estimation of subtraction of decimals.
Do I round off both decimals to the nearest whole number first too?
Yes.
Okay, 5.78 is 6 when rounded off to the nearest whole number, and 1.99 is 2. I then take away 2 from 6 and the answer is 4.
How about this one on multiplication?
No problem. 6.53 is 7 when rounded off to the nearest whole number, while 3.45 is 3. Therefore, 7 times 3 is equal to 21. The answer is 21.
Good. Do you think you can estimate the value of 4.78 divided by 8?
I will have to do long division to get that answer.
That is not necessary when you are estimating the answer. Bearing in mind the times table, what is the closest number to 478, which is completely divisible by 8?
I know that 48 divided by 8 equals 6. Therefore, 480 divided by 8 equals 60. So 480 is the closest number to 478, which is divisible by 8.
Right. We can rewrite 480 as a decimal with 2 decimal places in place of 4.78. 4.80 divided by 8 is 0.6.
I know how to estimate the answer in calculation involving division now.
What have you learned today, Turbo Boy?
I've learned how to round off decimals to the nearest whole number, to 1 decimal place, and to 2 decimal places.
Can you give me some examples?
Let me show you. When rounding off 8.99 to the nearest whole number, I look at the 10th digit 9. As 9 is greater than 5, I add 1 to the whole number 8. The answer is 9. When 4.67 is rounded off to 1 decimal place, it becomes 4.7, as the digit 7 in the 100th place is greater than 5. Thus, the decimal 4.67 is being rounded up. When rounding off 3.432 to 2 decimal places, I look at the 1000th digit 2. As 2 is less than 5, I drop the digit 2 and leave the rest of the decimal as it is. The answer is thus 3.43.
Very good. Are you able to tell me about estimation too?
Sure. To estimate the value of given decimal sum, we need to round off each decimal to the nearest whole number before we add, subtract, multiply, or divide them.
Very good, Turbo Boy. You take care, and I see you next time.
Goodbye.